Hello, this video is going to cover our 1.1 geometry notes. The title of these notes are points, lines, and planes. I do want to preface this video by saying that as we move through geometry as a course, we want to always make sure that we never assume things to be true. And I want to say this now, that way it's just kind of like stuck in your brain a little bit. In order for us to say that something is true, whether we're viewing something or we're reading a statement, there has to be a way that we can definitively prove that what this thing is that we are looking at is true. We can't assume it to be true. We have to know for a fact that it is true. So as we are looking through things later on in our notes, I want you to remember that we have to find proof of the thing to be true. If it might look like it's true, that's not good enough. I need actual proof that what I'm looking at is true. If not, then we are assuming, and we should not be assuming whenever we are looking through our geometry stuff. So I'm going to go ahead and get started on these notes. These notes are kind of boring because it's a lot of vocab, and I apologize, but everything that we talk about today is really important, especially how we name different things in geometry, such as points, lines, planes. We have rays that we're going to look at. We've got line segments and things like that. And so it's super duper important that we know how to name them, the symbols that are involved in each of these names. And then once we get through that, the rest of geometry is a lot more fun. At least I think so. Okay. So the three undefined terms of geometry are point, line, and plane. We're able to describe each of these things, but we just can't define them. So the way that we describe a point is a location. It is represented by a dot, and we name it by a capital letter. So if you look at these two dots below, notice that next to the first dot is the letter A, and next to the second dot is a letter B. So this we would consider these point A and point B. So we would name this as point A, or we could name this one over here as point B. We don't have to write the word point in front of it. A line is going to extend infinitely in two directions. So if you look at the line that I have below, you have an arrow pointing to the left and an arrow pointing to the right because it's extending infinitely in two different directions. We will name a line by any 2 points that are on the line, or you can name it with a single lowercase letter. A line symbol should be placed over each name except the single letter name. So all I'm going to need to do to name this line is choose 2 points on the line. It doesn't matter which 2 points I choose, and it doesn't matter the order in which I write these points. So for example, I could call this line AB. I've picked 2 points on the line, but I do need to put a line symbol over the top. I could have also named this line BA. I can also name this line BC. I could name this line CB. That line over there is not cute, sorry. I can name this line AC. I could name this line CA. And then I think that's all the different ways I can name it with those, with 2 different points that lie on the line. But the other way that I can name it is, do you see that there's this little lowercase letter over here? It does not represent a point on my line. So I'm able to use that little lowercase letter and name this line T because it does not have a, it's not a point on the line, and it is a lowercase letter that I'm using to write the name of this line. I'm going to make sure that I write it without a line symbol over the top. And just, I'm gonna redraw these because those looked kind of ugly. All right, so those are the different ways that we can name a line. Remember that you use any 2 points that are on the line. The order does not matter. All of those are acceptable names. Next, we're going to move on to a plane, and a plane is a flat surface that extends in all directions without end. In the picture that you're looking at right here, it does look like the plane ends, but that's because we have to draw borders in order for us to be able to visualize what a plane is. I like to imagine a plane as like a 8x11 white sheet of paper. Although paper does have an end to it, that's how I have to envision what a plane looks like, because that's the only way that my brain can actually envision it even remotely close to what it is. Okay. Planes do not have a thickness. So again, even though that sheet of paper that I referenced a second ago, it does have some thickness to it. It's not a lot, but planes don't have a thickness, okay? We will name a plane by a single capital letter that does not represent a point, so there's not gonna be a dot next to it, or by at least 3 non-collinear, and non-collinear means not in a straight line, points on the plane. So here we have an example of this plane, okay, even though it has a border on it, you just have to remember that the edges of this plane are infinite and they're just going on forever, okay? So the way that you would name this is you would choose any 3 points that lie on your plane as long as they do not lie in a straight line. So points A, B, and C do not lie in a straight line, so I could name this plane ABC. I could name this plane ACB. I could name this plane BAC, and so on and so forth. So the order, again, doesn't matter. But let's say that I had a point here, and this was point D. I could not name this plane CDB because C and D and B are in a straight line, and that would be considered collinear, and we can't have that. Now, do you see up in this upper right corner here that we have a capital letter that doesn't have a dot next to it? I could also name this plane P. I could not name this plane A because A is an actual point on the plane. Okay, let's talk about line segments. So now we're getting into actual vocabulary. And these things are actual definitions, because remember that we cannot define point, line, and plane, but the rest of these things we can define. So a line segment is going to be a segment that contains points of A and B, and on all points on line AB that are between A and B. So just bear with me when I show you this, okay? I have point A here and I have point B here. If I choose a point outside of B, I no longer have a line segment. I now am looking at points outside of B. And so anything that lies anywhere on this line here is considered part of line AB. If I'm looking at a line segment, I have my point A, I have my point B, and any point that lies in between points A and B are considered part of my line segment. So that's essentially what this is saying. It says line segment AB consists of points A and B, so you have my endpoints there, A and B, and all points on line AB that are between A and B, which is the pink that I have highlighted there. So none of these points outside of A and B are going to be included in my line segment AB. So when I write my line segment, I'm going to write it with 2 capital letters and a line segment over the top. So this is different than a line because a line has arrows on the side, line segments do not. The only other way that I could name this line segment is BA, and again, the order does not matter. So that's how I would name line segment AB. Okay, we're gonna move on to rays. Ray AB consists of an endpoint A. So if you look at the picture down there, notice that I have an endpoint A, and all points on line AB that lie on the same side of A as B. All points that are on this ray here are to the right of A. So B is to the right of A, and all the other points are to the right of A. So this is going to be considered a ray. And the way that we write a ray is the endpoint letter must be first. So this is endpoint A. It starts here. So I have to name this AB with a ray symbol going over the top of it. That is the only way that I can name this ray. Now, what I do want to point out to you, though, is this. I could have a ray that looks like this. And if I asked you to name this ray, remember that you must start with the endpoint. That must be your first letter. The endpoint is Z. So this will be ZC. And no matter what, when you draw your ray symbol must go to the right. So even though this ray looks funky in its positioning and all of that, it's still going to be written using the same order. So the endpoint must be first. You always write another letter that falls on that ray. And then your ray symbol must always be pointing to the right. Okay. Next, we have opposite rays. And opposite rays are 2 rays that share the same endpoint and form a line. Okay. So although this might be a little bit weird to look at, point B is the endpoint for this ray, and then point B is also the endpoint for this ray. So you have 2 rays who share the same endpoint B, and notice that both of these rays sharing endpoint B here are facing in opposite directions and are creating a straight line. So we would consider this opposite rays. This is not an example of an opposite ray. Here's A, here's B, here is C. Although these 2 rays do still share endpoint B, ray BA and ray BC do not form a straight line. Therefore, this is not an example of opposite rays, okay? So the opposite rays that I have here are ray BA, and the other opposite ray that I have, or the other ray here, is BC. So notice that both of these start with the letter B, okay? And both of the arrows are going to be facing the right, even though ray BA is facing the left, okay? But those are my opposite rays. All right, we're going to move down and talk about collinear points. So collinear points are points that lie on the same line. We talked about this briefly earlier. The line does not have to be drawn in order for us to say that we have collinear points. So what we're going to do is we're going to look at each of these sets of points and determine if they are collinear, that they're in a straight line, or they are non-collinear, they are not in a straight line. So if you look at points A, B, and C, hopefully you can see pretty quickly that points A, B, and C are for sure collinear. They lie in a straight line. What about D, E, and F? If I were to connect those, are those in a straight line? Definitely not. So these would be considered non-collinear. All right, if I look at point F and A, point F and A are kind of far apart from each other. However, the question you have to ask yourself is, can I draw a straight line between point F and A? And the answer is yes, you can. Okay, so even though the line was not drawn, I could draw a line and points F and A would be considered collinear. The same thing is true with D and E. Even though a line is not drawn between the two of them, I could draw a line between the two of them and that line would be straight. So we would say that D and E are also collinear. Now there's this really important thing that I have down here for you, and it says any blank points are always going to be collinear. Anytime you have 2 points, no matter what 2 points they are, you're always going to be able to draw a straight line between them. And if you don't believe me, draw 2 lines anywhere on your paper, or draw 2 points anywhere on your paper, draw a straight line. You're going to be able to draw a straight line between those two. Okay, this is important information, by the way. Okay, you're not going to want to forget that. Any 2 points are always going to be collinear no matter what. They don't have to lie in the same plane. They can lie in different planes. It doesn't matter. They will always be collinear. All right, next we're going to move on to coplanar points, which are very similar to collinear points. Coplanar points are points that lie on the same plane. Remember that planes are infinite in their length. Okay, they're going to look like they have a border because visually we have to see some kind of border there, but they are actually infinite. The plane does not have to be drawn in order for us to say that points are coplanar or not. And remember, in order to name a plane, you only have to have 3 points. So I want you to think about that. Here it says label the following points as coplanar or non-coplanar. So I'm looking at points A, B, and C. Here's point A, B, and C. And if you look at points A, B, and C, they all lie on the same plane, and the plane that they lie on is at the bottom of this cube shape. I do not have to include point F in the determining if this is a plane. You only need 3. So we would say that these 3 points are coplanar. We can draw a plane with those 3 points there. Next, I'm going to look at G, E, B, and C. Here is G, E, B, and C. This one's going to be a little bit funky, especially because a plane is not already drawn here. But you have to ask yourself, can I draw a plane between those 4 points? And yeah, you can. The plane that we're going to draw is going to be a little bit funky. The plane is going to end up being kind of on a diagonal like this. It kind of goes from the upper edge of one part of my cube to the bottom edge of the other. So this would still be coplanar. Remember, the plane does not have to be drawn, but you should be able to draw a plane between those points. All right, moving on to the next set. We've got F, G, A, and C. Here's F, here's G, here's A, and here's C. So if I look at this, let's say that I ignore C for a minute. If I don't look at C, then I can say that that plane exists over there, okay? But when I include C, I'm trying to figure out how I would be able to create a plane between those 4 points, and I don't think I can. If I get rid of G, then those 3 points down there would represent this plane. So as of right now, I'm not really seeing how I could draw a plane between those 4 points. So this would be non-coplanar. That word is long, I don't have enough space. Okay. Let's look back at points E, D, A. So here's E, here's D, here's A. I can draw another diagonal plane. there. And even though B was not included in my letters, it doesn't matter because you only need 3 points to name a plane. So we would say that these are coplanar as well. And I don't know if you've caught on to the pattern here or not, but the pattern essentially says any 3 points are going to be coplanar. So D, G, and C, I don't even have to look at it. I already know that they're going to be coplanar. And then the same thing with this last one because there's only 3 points here. So I'll always be able to draw. Oops. Let's try that again. Coplanar. There we go. And just like up above where we said any 2 points are collinear, it's really important for you to remember that any 3 points will always be coplanar. Okay, now remember earlier when I said don't assume things to be true, we have to have definitive proof. Here is a really, really good section, okay? In this class, we do a lot of true-false in this first unit because we need to know what you know without assuming and what you are assuming, okay? And we should never be assuming. Remember that we always want definitive proof that something exists, okay? So it says, based on the figure at the right, label each statement as true or false. So what we're gonna do is we're gonna first look at VY is the same as YV. It's important that you look at the symbols at the top of these. Both of these symbols are line symbols. And if you think back to when we did our lines, remember that you can name a line using any 2 points and the order doesn't matter. So I am going to look at YV, which is here, is going to be the same as VY, which is also here. So those 2 lines are the same line. They just switched the order of the letters, but that is okay. So this is going to be considered true. Okay. All right, let's look at this next one. It says ray XZ. So with ray XZ, I know for a fact the endpoint is X and Z is this direction. So that is ray XZ. It says ray XZ is the same as ray XW. Well, here's X and W is also over here. Does it matter that they chose point Z as the endpoint, or not the endpoint, but as the second letter of the first ray and W as the second letter of the second ray? It doesn't matter. They're still the same ray. They have the same endpoint, and Z and W are still on the same line, and they're on the same line on the same side as X. Z and W are both to the right of X, so those would be considered the same ray. So this is also going to be true. Hopefully that made sense. I know I just like word vomited. Okay, number 3, it says VZ is the same as VZ. One is a line and one is a line segment. If you compare a line and a line segment, they're never going to be the same. A line, remember, extends infinitely in both directions, and a line segment is a very specific length within a line. So lines will always be bigger than line segments, so there's no way that they're going to be the same. They did use the same letters, but remember that in a line, if I'm looking at VZ, this is line VZ, and then this is the line segment VZ. And they're not the same. There's no way that they're going to be the same. So this is going to be false. And if you need to make a note to yourself why we said that that's false, you can write that off to the side. All right. It says line segment WZ is the same as line segment ZW. They have the same letters. They're just one is written in a different order than the other. It doesn't matter if they're written in a different order. WZ is going to be the same as ZW. So we're going to say that this one is true. All right. Number 5 says YZ is the same as YV. So here's YZ. That's line segment YZ. And then it says YV. Here's line segment YV. Are those the same segment? And the answer is no. Obviously, one is shorter than the other. If it asked if they're the same line, we would say, of course they are. But when we're looking at line segments, there's no way that they're going to be the same. So we are going to label this one as false. All right, looking at number 6, XZ is the same as XW. Ooh, there's too many letters here. So line XZ is this one. Okay, it's going on forever in both directions. And then XW is actually going to be the same one. They're going in the same direction. They're on the same line. The letters that they chose to use are just different letters, but they're all on the same line. Lines go forever in both directions, so we're good here. So this one's going to be true. Okay. Number 7, another name for ray ZX is ray ZW. So here is ray ZX, and then here is ray ZW. Are those the same ray? The answer is no. Those would be considered opposite rays, but they're not the same ray. They do have the same endpoint, but they're not going the same direction. So there's no way for those to be the same. Okay, number 8, another name for line ZV is ZY. Let's see, here's line ZV, here's line ZY. Those are the same line. Lines are a little bit easier for us to determine if they're the same or not. That's going to be true. And then ZV and ZW are opposite rays. So here is ZV. Remember, here's the endpoint. It's going this direction. And then ZW starts here and goes this direction. Although they share the same endpoint, remember that part of being an opposite ray means that they have to make a straight line. That does not make a straight line. So this one would be false. Okay. All right, and then this is the last part of these notes. We will see a question like this on the test, so it's really important that you remember what we discuss here and make like a note to yourself, like you will see this on the test. All right, it says, using the diagram below, answer each question. Be sure to include the proper symbol for the name. What is the intersection of plane ABH and plane HBC? Okay, I'm gonna go find plane ABH. Plane ABH looks like it's the front plane on this cube. Now, we are dealing with planes, and one of the things that I keep reiterating to y'all is that planes are infinite, okay? They go forever in all directions. So even though we are looking at something that looks like it has a border to it, in reality, it doesn't have a border, okay? So just imagine that those black lines aren't there, and it's going up and down forever, and then side to side forever. But it's the front of this cube, if you will, okay? And then we need to look at plane HBC. Plane HBC, it looks like it is the right side of this cube. Here we go. Scribble, 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 scribble. Okay, so what we need to do is we need to determine what the intersection of these two planes are. And if you look very closely, hopefully you see that this line here is where those two planes intersect. So the intersection of two planes are always going to be a line. And we're going to call this line HB, or you can call it BH, but you do need to put a line symbol over the top. Although it looks like a line segment based in our picture, remember that planes are infinite in all directions. So that edge piece that you see there on HB, although it looks like a segment, it's actually a line. So we're gonna name it line HB. Erase. Let's look at the next one. Okay, we've got plane GEH, that's the top plane here. And then line ABH, which is our front plane again. I guess I didn't have to delete that front plane. Okay, ooh, sorry. I picked up my pen and now it's gonna look funky. Now, whatever. Okay, so we need to determine the intersection of those planes, and hopefully you can see that those planes intersect at line GH. So we are going to write GH with a line symbol over the top. Okay, so remember the intersection of planes are lines, okay? Erase. Next, it says, what is the intersection of line GH and line BH? So where is GH? GH is here, and then BH is here. Where do those two lines intersect? They intersect here at this point, so we're going to call this point H. And then again, we're gonna look at GE back here and FE, which is this one back here. They intersect both at point E. So we're going to say the intersection of lines are points, okay? This is gonna be really, really important for you later. All right, so that is it for these first set of notes. Thank you for coming along with me. If you have any questions, please go see your teacher at their normally scheduled tutorial times. And I will see you guys in the next video. Bye.